So today we are going to discuss about the data transfer instructions. In the last classes we studied arithmetic instructions, logical instructions, and one more, it is the data transfer instruction. Data transfer is nothing but, as the name indicates, data transfer. How can you transfer the data from the source to destination or some locations to some other locations? So basically we know that data transfer, basically we seen the many of the programs by using the move instructions. So that means by using the move instructions, so we are going to this is the destination, this one is the source. That means from the source to the destination we are perform the moving by using the MOV instruction. But apart from this MOV also, we can perform the transferring the elements or transferring the data by using the some other instructions also. So what are those here? So we need to study here. Here I listed some instructions. Those are the MOVX. So this is including the, this is entire characters is including the one instruction. It is not like that with the space, move space x and not, that is invalid. So you have to write it continuously, move x. This is the MOVC, push and pop. This is the XCH. XCH stands for the exchange. So only thing is already we know that MOV instructions, move, is it clear? So if you add after the V letter, if you add the X, that is the one of the instruction, move X. So MOVX. If you add the one more C letter after the V, it becomes the MOVC. Is it clear? So that means here the four instructions are there. We need to study by the one by one here. So before going to start the first instruction, move X or move C, first we try to see this diagram. So this diagram already seen in the last classes, regular classes in the colleges. That is when you are going to interface externally. So that is nothing but when you are going to interface 8051 or 8031 with the some external to the RAM or external to the ROM. That is the same connection we can see here. This is your 8051. So this is your external RAM. So this is your internal or external ROM. So that means same thing when you are connecting to the 8051 here, this should perform the read and write both the operation with respect to the RAM here. ROM in the sense it can perform only the read operation because this is a read only memory. This is random access memory. So in this diagram we can observe some few things here. So this is register A, accumulator, R0 and R1 register, DPTR, data pointer. So already I said in the previous classes, A, R0 to R1, R0 and R1, these are the 8-bit register. DPTR is the 16-bit register, and DPTR plus A and program counter plus A. Program counter also, this is a 16-bit register. So if you understand this diagram, it's very easier to understand your instructions, move X or move C. Is it clear? If you want to transfer the data or if you want to communicate between the RAM with the 8051, here we can see only the two arrow mark we are going to show. Two arrow mark is nothing but this is a move X at RP. So one more is the move X at DPTR. Only two arrow marks are there. When you are going to transfer the data in between the ROM to the 8051, there are again they return, instead of move X they return the move C, A comma at rate of A plus DPTR. One more is the move C, A comma at rate of A plus program counter. That means you can understand easily. When you are going to make data transfer in between RAM with the 8051 controller, only we need to use the move X instruction. So here the MOV stands for move instruction, that is the data exchange in between the RAM locations only, internally. So but when you are moving the data in between the or accessing from the external RAM, so at the time we need to use the move X. X stands for data is sharing or data is moving in between the controller with the external RAM. So that means this X stands for this is the external. So this instruction only we need to use for the only the RAM. One more thing, move C, when we can use the move C here. So when you are moving the data in between the ROM with the 8051 or with the microcontroller, or sometimes the ROM also we can call it as the code memory or the program memory. This one we can call it as the RAM, also we can call it as the data memory. So that means when you are moving the data in between the ROM with the controller, at that time we need to go for the move C instructions. So you can understand one more thing, when you are using the here one more thing, add trait, we return the everywhere add symbol, add trait. That means mainly the move C and move X, they are going to use the indirect register addressing mode. And already said, if you are using the indirect register addressing mode, is in the sense only we need to use the R0 and the R1 as the pointing register or the pointer registers. And here everywhere in the ROM data transfer between the ROM with the microcontroller, we are using one of the register is the accumulator itself. So try to understand this block diagram, then your instruction side becomes very easier. And also here when you are using the R0 and R1 register, maximum it can address the 00. So that means when you are using R0 and R1 as a pointer register, maximum it can address 00 to FFH only. If you are using the data pointer DPTR, it can address from the 4 zeros to the 4F, because of this is a 16-bit register, but this is the 8-bit register. So just we can see the instruction one by one. So let's start the first one, move X instruction. This is the external data moves. Just as seen your previous diagram, it is the external data moves in between the RAM with the the microcontroller. And also all the external data moves must involve the accumulator register. You can see the some of the mnemonics here. Everywhere you are using the one of the register as the accumulator, that will be the fixed. You can see the some example. Move X A comma at RP. RP in the stand for, this is a pointer register. P stand for the pointer register. When you already I said everywhere it can support move X instruction, it support mainly the indirect register addressing mode. Indirect is nothing but this is the RP pointer register. It should be R0 and R1 only. So that means what it's saying, the first example, copy the contents of external addresses. So that is nothing but this is the add trait is nothing but the content of the address which is held by the R0 and the R1, it moving to the accumulator A. Similarly, move X A comma add trait DPTR, that is nothing but copy the contents of the external address which is held by the DPTR to the accumulator itself. And try to understand, this is the 16-bit register, this is the 8-bit register. So that is nothing but maximum it can access only 00 to FF. This can access maximum, start from 000 4 zeros to the 4F. In third one, what is saying here, move X at RP comma A, copy the data from accumulator to the external address which is held by RP, that means R0 or R1. Move X at space at DPTR comma A, copy the data from DPTR, address location which is held by DPTR to the A here. So this should be the DPTR to A. So just to try to see this examples here, mainly all the instruction it mainly consisting of the one of the register is A, and it is going to support the indirect register addressing mode. And here mainly this is the data transfer between the external ROM. Externally it is going to perform only the externally in between the ROM with the microcontroller. That's why we are writing the move along with the X letter. So we'll go for the next one, move C instruction. So move C instruction, this is the code memory, or we can call it as the program memory, or we can call it as a ROM, read only data moves. That is nothing but move C we are going to use for the data transfer in between the ROM with the microcontroller. That's why we are going to add here the C here. C is nothing but this is stand for the move data from the code memory. So that's why this is the C. In previously we written the X. X stand for, this is the data movement from externally. That's why X is there. So here T stand for, this is the code memory. Code memory in the sense that is the ROM itself. So that means what we can say here, when you are moving the data transfer in between the ROM with the microcontroller, at the time we are going to use the instruction MOVC here. And it is also uses the indirect register addressing mode, and A register is in conjunction with either of program counter or the DPTR. So previous diagram, just to check it once, in that diagram we are going to use the data pointer or it may be the program counter. That means we need to use any one, not the both. Any one of the register we need to use, that is the data pointer or it may be the program counter. And just to see some example here, move C A comma at accumulator plus DPTR. That means address location held by the accumulator is going to add up with the address location held by the DPTR. So that means entire add rate, it is for the entire A plus DPTR. That is nothing but address of the accumulator is going to add up with the address of DPTR. And finally what you are getting, the final address, it is going to indicate with the add rate. Similarly here, add rate A plus program counter. That means you can use data pointer or you can use the program counter. Any one you can use. That one we written here. A register is in conjunction with either program counter or it may be the DPTR. You can see the one example here. Move DPTR comma hash 1234H. This is the immediate value I am loading to the DPTR. So that means address which is held by the DPTR is the 1234H. Similarly, move A comma hash 56H. Then value, this is also immediate. What is the value of 56? It is loading to the A. That means this is 56. What it does in third instruction, move C A comma at rate of A plus DPTR means value loaded by the A. That means we can say address loaded by the A 56 and address loaded by DPTR is 1234. After performing the addition here, that means 1234 plus 56 means here 4 plus 6 means 10. But in hexa that is the A. 5 plus 3 8 and 2 as it is, 1 as it is. That means 128A. So this is becomes in location of this is the source. That means instead of writing A plus DPTR, it becomes the 128A. That means our rate of 128A means data which is present in the address location of 128A is moving to the accumulator. So that is the meaning of rate A plus DPTR. This is the sum of address location which is held by the accumulator with the DPTR. So similarly, instead of using the DPTR, if you write this is the just program counter. So here also if you write program counter, this is the one more example with respect to the rate A plus program counter. That means when you are making the transfer between the ROM with the microcontroller, at the time we need to use the move C instruction. C stands for code memory. And second thing is we need to use only the registers DPTR or with the program counter. Third one is we need to write the instructions like this is destination. In the source side we need to write add rate of A plus DPTR or A plus program counter. Fourth one, this instruction is going to tell like that this is the sum of address which is held by accumulator plus address of the program counter or the DPTR. So here also we are going to use the A register everywhere. So this is very important and try to understand this one.